So once we've assigned priority, we can do what we call assigning a configuration. If you recall on a previous slide, I said that the groups around the central atom, these groups here, could be oriented clockwise or counterclockwise. Well, we have a little bit of an issue here because in order to assign a configuration, we first have to take this molecule and reorient it such that the lowest priority group is facing away from us and the top three groups are facing out at us. So in order to do this, I want to show you this in 3D. Alright, so here is A, right? And I want to take A and I want 4 basically to face away from me, and I want these three groups here to be facing towards me. So let's look at that. So if I take A and I turn it this direction, right? Let me correct that Z just a little bit. Right? What you notice is that 4 is now pointed away from me, and the top 3 priority groups are now facing me. We call this the steering wheel configuration. Alright, let's look at it again. So here I have A, molecule A, right? And I'm just looking at it, and let's just turn it around so you can see the whole thing. Right, so here's A. I'm just going to rotate it a couple of times. Here's the hydrogen, here's the CH3, right? Here is the OH group, and here's bromine. Alright, so let's stop that here, and let's just turn it a little bit more. So here's hydrogen, bromine, CH3, and OH. Alright, so what I want to do when I'm reorienting this thing is I want 4 pointed away from me. I want the lowest priority group away. So I just take A and I turn it this way, and then I'll correct it a little bit so it'll look straighter. But you'll see here now these 3 groups are pointed out at you, and then 4 is pointed away from you. And so that's what it means when to say to take the molecule and reorient it. And we're going to talk more about this. So let's go back to the PowerPoint. So what I want you to see is here's A. The priority has already been determined. And now here is A in the steering wheel configuration with hydrogen, or the number 4 group, facing back. The top 3 groups pointed out at me. And so if you will look here, this is 1, this is 2, this is 3. And so if I want to assign configuration, right, if the groups are oriented clockwise, then the configuration is R. If they're oriented counterclockwise, the configuration is S. The R and the S are Latin terms, R meaning rectus or right hand, and then S meaning sinister or left hand. Okay, so here this is 1, this is 2, this is 3. These 3 groups are oriented in a clockwise fashion, and so the configuration here is R. Alright, and we'll do some more complicated examples another time, but let's look at that 3D again. So I'm going to go back to here. Alright, this is where I started, right? And then I wanted 4 pointed away, so I just rotated this direction, right? And now 4 is pointed in the back. The top 3 groups are pointed out at me, and so now I have this in the steering wheel confirmation, and I can just determine whether the groups are oriented clockwise or counterclockwise. Now, one of the things to remember is this: it does not matter how many or which way I rotate this thing. This is still 1, 2, and 3. If I turn it again, this is still 1, 2, and 3. If I turn it around again, this is still 1, 2, and 3. As long as I'm not changing the position of the atoms, then the configuration will never change. Alright? If I change the atoms and put CH3 here and Br here, then that changes the configuration. But if I'm just rotating it in space, the configuration never changes, and because of that, I'm able to say with certainty that this is R no matter where it is located in space, right? And it's R because of the way that the groups are arranged around the central carbon. Alright, so you see again, this is 1, 2, 3, that's clockwise, and so the configuration is R. Alright, so here's your turn. Can you tell me the configuration of these molecules? Right? I made it easy because 4 is on the dash. That means it's already pointed away from you. So looking at 1, 2, and 3, can you put this molecule in the steering wheel conformation, whereas you only see the top 3 groups and you don't see the 4th group? And can you determine the configuration? Well, before you do that, you have to determine the priority, which I've already done here. All right. So your job is to put it in the steering wheel configure or confirmation, and then determine whether it's R or S. All right. So when we come back to class, we're going to talk more about configuration. We're going to talk about Newman projections, more complex molecules, and even glucose, because glucose is one of those molecules that you'll see on your standardized exams, and we'll talk about other stereoisomers, in this case diastereomers. So if you got any questions, you can email me, you can tweet, or you can come by my office. All right, peace.